Okay, hello all. This is going to be the revision on the final, where this video will covers on the calculation part after midterm. Alright, so first and foremost, the disclaimer is please be advised that this document, right, it just for revision purpose. It does not intend any tips or any guidance in your final. Okay, so just a quick one key content for this video. We are going to go through memory partition technique, first fit, best fit, and worst fit. Then we have page replacement algorithm, first in, first out, least reason use, and optimal. Okay, then we're going to go through a quick calculation on logical address and physical address, and lastly, the 6 strategies: first come, first serve, shortest seek time first, scan, and also look. Right. So I'll split the video into a few parts, so you just feel free to use it. Now, go into the first one, which is memory partition technique. In this chapter, right, you will actually learn about the fixed partition and also dynamic partition. Make sure you know what are them first lah. Okay, for this question, if they didn't mention about it, right, we are just going to treat it as a fixed partition. And on right here, you have your free space list and the queuing process. Okay, look into this one. This is a question from your sample past year. Show these 6 processes are allocated into memory partitions when the following allocations algorithms are applied. Give your answer using the following table format. If they already give you this table format, right? 如果他有给你这个 table format, 你就跟。OK 你如果自己去画 table format 不是不可以 but 如果很像你只是写了 let's say 你没有填到这个 process size， 我们有权利不给你分。OK， so 如果给了这个 just follow 啦。Now first fit, okay, there's 3 fit over here. First, best and worst， 怎么样去 differentiate 它？ First fit 很简单。Which process come first? If the partition is able to fit in the process, you just fill it in. 什么意思啊 ？OK， 你先看on 这边这一个是那个 fixed 的那个 partition 来的，就是有的位置，空的位置。on 这里是 process your process size。Okay, so over here you have the partition which is free one that just imagine it as a memory, and over here this is the process that take up what is the size of it. Imagine you want to run process 1, you need 170 size. Okay, so to do the first fit, right, basically you're trying to fitting all these process, right, with the required process size into the free space. So 这个是你的空位，这个是你跑 process 需要用到的位置，所以你会把这个东西 fit 进来你的 free space 里面。Okay, make sure you're clear about this. So in that case, 要 fit 要怎么样 fit？ 好像 process one, should the process one go into partition A or go into partition B or go into partition C? How we determine that? We will base on the allocation algorithm. So there are 3 algorithms over here, which is first fit, best fit, and worst fit. Okay, the first one, first fit, which is the easiest one. How do we do the first fit in this way? Okay, so because we have this table format, right? Apologize if my handwriting is a bit jittery. Okay, I hope you should be understanding what I'm writing over here. So basically, I'm trying to copy the table only, and this is to ease the process at the last part. Okay, process size and internal fragmentation. Okay, so how do you determine is it fixed? Because some of the students actually feedback to me, right? Some of the questions they will state here that this is a dynamic partition or whatsoever. If they didn't mention, how do you differentiate? Is it a dynamic or fixed? You look into this one. So 哪一个partition 会 cause internal fragmentation? Okay, you go back and study. You should be knowing all this theory for what I've mentioned here. So you have for the partition, right? There's 2. First thing is the fixed one, okay, and the second one is dynamic. Okay, so for fixed, they will have fragmentation. Dynamic will have fragmentation as well. For fixed, it will going to cause you internal, while for dynamic, it is going to cause you external. So for this red part, if you still don't know what I'm mentioning, when you're trying to watch this video, right, go back and study on your own, please. Okay, now for the first fit, now go into here. I write partition size, process size, internal fragmentation over here. So you have A, B, C, D, E, F. So very easy in your exam. You just list down A, B, C, D, E, F. with their respective size. Okay, so I put KB over here lah. So I know this one is 500, 350, 150, 400, 350, and 200. Okay, so this is the case. Now, to fit it in, imagine here, now you are doing first fit. What does it mean by first fit is, process 1 start first, right? You go through the sequence like this, macam ini. So, from P1 慢慢走到 P6, okay? Start from process 1 until process 6. So, to do first fit, we see that the process 1 come first, the size is 170. And you look into the partition 1, which is size of 500. 170 is smaller than 500, right? It can be fit into partition A, right? So first fit, we directly fit the process 1 into the first partition because it can hold this process size. Okay, if you cannot follow, you listen here again. How do we do first fit is when the process come in, okay, one process at one time. So process 1 come first, it comes in. The size is smaller than the partition size, which means that particular partition can hold the process, okay? We don't care what is the value of the fragmentation, we directly just put it in. So 这个170小过500 ，imagine 容量是500 ，process 1 170，500可以装170吗？可以 ，OK， 直接 fit in， 这个就是 first fit, the easiest one. As long as it can fit, we just directly put it in. Okay, so process 1, we put it in, and the process 1 size is 170, right? So internal fragmentation is, okay, imagine I already say this one is the memory, right? Your memory here got 500 space. You put the process in, right, 170. Let me change one color. Maybe 170. Okay, process 1 over here. You just use up 170. So all here are the remaining, right? Okay, one thing, theory thing, if this is a fixed partition, you already put process 1 in, can I put process 2 in as well? You say, hey, here still got the remaining space, don't waste, I put other process in, can or not? Cannot, fixed partition, one partition can only hold one process. Okay, so all of this remaining is actually a waste. So to calculate the internal fragmentation, what you have to do is you use 500 minus 170. So this one is original space. This one is the space that you have used up. So your fragmentation will be what? You go and calculate. Okay, so this one I'm not going to do calculation. I'll just teach you how to store the, how to fit it in only, okay? But no worries, the answer I will provide as well. So you can do it on your own and check. Okay, the best way is you watch my video and then you do it on your own, then you check answer. You don't just every step follow me. Now, the next thing, we done the process 1 already, right? Okay, so process 1 is now done. Let's look into process 2. Okay, process 2 size is 420. Partition A is already filled, so I cannot put anything into partition A anymore. Now, 420, can I fit it into partition B, which only have 350? So the space is 350, but your process is 420. It is not sufficient, right? So not enough space for this process. So you cannot put a P2 here. What about P2 put into partition C? C is only 150. 420 is still more than the space available, right? So cannot as well. Then you continue to look, 400, smaller than 420 as well. Partition E 350, smaller than 420 as well. What about F, 200, smaller as well? Which means at this moment, your process 2 cannot put into any partition B, C, D, E, F because the size is 420. Then you see all this remaining, right? There's nothing can hold 420, right? You cannot say combine. You say, hey, can I combine into partition B and C? Then I can hold process 2 already. All combine. Okay? So let me continue here. Okay, so in that case, what will happen is in exam, please make sure you write this thing down. Okay, in your exam, you have to write that P2 is weighting. Okay, or if you don't want to write weighting, you want to say is in Q. Yes, feel free to do so. As long as you can bring the meaning where the process 2 cannot put into any partition because there is no available partition. So P2 is waiting over here. Okay, with that being said, our process 2 is done as well. Now go into the next one, process 3. Process 3 is 280. Okay, the next available partition is 350. Can fit 280 or not? Yes, can. So we just put process 3 and then the size is 280. Alamak. Okay, so internal fragmentation will be 350 minus 280. Okay, so that will be your answer. I'm sorry, this table is a bit messy. Just let me know if you guys don't understand. Then maybe I have to record again in a spreadsheet or something. Okay. Now, followed by the next one, which is 3 is done. We go to process 4, which is 90. So the next available partition will be 150, and this is just 90. We can fit it as well. So your partition C, right, you are going to fit in process 4 with the process size of 90. So your fragmentation will be the available space minus the process size. Okay, then you get your answer over here. All right, the next one. Process 4 done. We go into process 5. Okay, process 5, 220 size. Okay, so the next available what A, B, C, D is not used, right? Alamak, 乱到我自己都看不明白. So you see, in your exam, make sure you don't do this, else you'll be like me, okay? I can't even see what am I doing right now. 对. Maybe I use a red color. Okay, this is just to check where am I. Alamak, cannot. I'm try to draw a line here so you guys don't. And this one is C. Okay, I hope this make it clearer for you to see lah. The next one. So the next process is process 5220, and the next available partition is donkey 400. 400 can fit 220, right? So you put a process 5 here, and then your size is 220. Internal fragmentation is going to be the size, deduct the process size over here. Okay, so this is for the process 5. Now process 5 is done. The last one, which is process 6, 200, right? So 200, the next available is E, which is 350, can fit process 6. So you put it in process 6, and then 200 over here. So 350 minus 200, then you get your internal fragmentation. So over here, I draw line as well for you, easier to see. By the way, but the line is a bit chacat. Hope you don't mind. And then the E. Okay, so this is the case. With that being drawn, right, then you see over here, partition A, B, C, D, E, all you have the internal fragmentation over here. Okay, what about F? Because there is no process in F, so the internal fragmentation you cannot calculate. You put one dash over here. Okay, in your exam, make sure you use ruler. Don't be like me. Okay, do it neat and tidy, please. Okay, so this will be our final table for the first fit. Any question? No one's going to respond to me. Oh yeah, make sure this thing is in your exam script, answer script as well. Okay, because the process 2 cannot fit in. So process 2 is actually in Q. And that will be the answer for first fit. So to make it simple, first fit is like, you look at the next available partition. If it is smaller than the process, if the available partition size is bigger than the process size, which means can fit in, right? You just put it in. That's it. Okay, and look into the question as well. Now they say give your answer in the following. Okay, even though it says like this, right? It's better for you guys to practice after you calculate all this internal fragmentation. Okay, make a sum of it. Okay, and then you write it as the total of internal fragmentation is how many? And make sure you write the unit as well. Okay. So that will be first fit. Okay. If there is no question, what am I talking? Yeah, absolutely no question. I'll go into the next fit. Okay. And to make it simple, I might Should I pause the video here? It's okay. I think we can just continue without splitting it into another video. So the next one, best fit. Just now, the first fit is directly, you see the partition can hold the process size, right? Then you just fit it in. Now, best fit will be a little bit slower, okay? But they will fully utilize the partition. How do I say that? In best fit, we try to reduce the internal fragmentation. Okay. Now, how do we try to reduce the internal fragmentation in best fit is, okay, just now first fit, right? You see, oh, this memory space can hold this size, I just put it in. Best fit, we will scan through all the available partition and see which partition will give us lowest internal fragmentation. What does it mean? Look into here. So you see, process 1 is 170, right? We have A, B, C, D, E, F partition. So 170, if I fit into A, okay, what is the internal fragmentation? If we fit into B, what is the internal fragmentation? So to do best fit, you have to go and scan through and you see which one actually give me the lowest fragmentation. Okay, or I use Chinese to say 你这样子比这个170的这个 size 对不对？你放进来这里这几个 partition 哪一个是浪费最少的？So 170你可以放150吗？不可以，因为它小过你的 size 嘛。这样子500、350、400、350和200，哪一个你把170放进来，然后你减了，你拿到最小的那个fragmentation， 就是浪费最少的。所以在这个情况，你一看就知道是200啦。Okay, so to do this, right, let me get a blue pen as well. Okay, so I still have to draw the table lah. Okay, I'm sorry the table is chacat on my side, but you guys can do it in the spreadsheet or something when you are trying to practice on this thing. So we have process size in KB, and then the last one, which is internal fragmentation. Okay, so the first one, just like what I've said, to do the best fit. Oh wait, I should actually copy down this first. A, B, C, D, E, and F. Then try to draw a line this time so that it doesn't look that messy. And you guys are easier to understand as well. A, alamak, the line doesn't went well here. Okay, you can fast forward if you're watching this recording. Fast forward this part. Okay, now it works well right now. Okay, so I already, no, okay. Let me just write the size. So this one is 500, 350, 150, 400, 350 again, and 200. Okay, now let's do the best fit. Okay, now you see the first one, 170 process 1. Okay, the partition that can give us the least fragmentation or least wastage, right, would be partition F, because 200 minus 170 is just 30. Okay, the fragmentation is the least one. So you put process 1 over here. Excuse me. No, not here. Excuse me. So over F, okay, you put process 1. Yeah. And the size is 170. So to calculate the internal fragmentation, you do 200 minus 170, which will make you get 30. Okay, so this is the case. Now, process 1 done already. Let's move on to the next one, process 2. Okay, let me erase this one. Now, process 2, right? The size is 420. So you scan through again. Oh, here, which one can put in 420? Meanwhile, it will give you a least fragmentation. So after you scan through, must be this one 500 lah, the only one that can hold process 2 and 420. So fragmentation will be 500 minus 420 and you will get 80. Okay. Now process 2 done. Move on to the process 3, which is 280. So you see over here 350, 400, 150, 350. Which one give you the least fragmentation? Okay, so for here the answer will be 350 lah. So you see B and E, right, both are 350. Which one should you put? Actually, it doesn't matter. Okay, but my practice, I will going to put it into the B lah. P3, 280, and then 350 minus 280, and then do some calculation. 350 minus 280 will be 70. Okay, now P3 is done. The next one, P4, 90. So 150, 400, and 350, which one actually give you the least fragmentation? Definitely 150 lah. So you over here you write process 4, and the size is 90. So the internal fragmentation is going to be 150 minus 90. So we're going to be 60. Okay, and the next one, process 5, 220. So 220, which one put into which one will give you the least fragmentation? Definitely 350 lah, because this number is more nearer to this one, right? So you just put it in process 5 and then 220. Internal fragmentation would be 350 minus 220. So 350 minus 220. Okay, don't doubt, I'm pressing calculator as well. Okay, 130. And the last one, process 6, 200, you put in here. Okay, you might think that, hey teacher, best fit want the least internal fragmentation but this one 200 I put into 400, also a lot of waste, right? What do I do? Okay, listen here. If the partition is able to hold the process, right, we rather process it with fragmentation instead of make it to be waiting. Okay, instead of make it to be waiting or in queue status, right, we rather put it in. Okay, so if you're wondering that this partition D, right, quite a lot of internal fragmentation, it doesn't matter, because at this moment, this would be the best fit for this case. Okay, so at here you write 400 minus 200, so you get 200. So there's no job waiting. You can say no job or process waiting. And you sum this up. Here you do the sum of here. And you say the total internal fragmentation is what kind of value, and then followed by KB. So this is the best fit. Okay, so that's all for the first and the best. Okay, the next one, worst fit. What does it mean by worst fit? So just to sort of like to revise back lah. The first fit is, okay, imagine this is your memory space lah. Okay, first fit went in a way, oh, this one can fit, we put it. Oh, this one cannot fit, and then I go to the next one. Then can already, I come back here, something like this. Okay, it's like process. If the partition can fit, we just put it in. If cannot, then we go to the next one. Cannot, we go to the next one. Cannot, we go to the next one. Cannot, we go to the next one. This is first fit. Okay. Meanwhile, the best fit is when we try to enter here, we scan first. You go down, you go up, okay, and you see which one is the best one. Oh, you think this one is the best one, then you fit here. Best fit. Worst fit is on in contrast. Okay, in a way that, right, you fit it with the highest fragmentation, highest internal fragmentation. Which one give you more wastage of the memory space? You fit it in. That is called worst fit. Okay, example, this process 1 is 170, right? If it is first fit, we just put into partition A. This one is first fit. Now, if it is best fit, we scan through, okay, we go up and down, and we think, oh, F will give us partition F 200, right? The least fragmentation of the D only. This one you fit, best fit is in partition F. First fit is in partition A, because the easiest ones, you just go through, okay, this one can hold, then we put it in. So this one is first fit, and this one is best fit. Now, in the condition, if process 1 is go through a worst fit, right? What you do is you scan through, okay, and you choose the value which is having the highest fragmentation. So you see 200, 350, 400, 150, 350, and 500. Out of all these value, right, which have the biggest difference with 170, which is 500 lah. So if it is in worst fit, we'll also fit the process 1 into partition A. If you cannot follow, never mind. You just do step by step, okay? Try to master each of the fit first. Okay, now I'm just gonna focus on this worst fit. Okay, what I have to do is I still have to draw the partition. Okay, so give me some time to actually come up with this partition size kind of thing. And then we're gonna have a process size, and followed by the internal fragmentation. Okay. I fill in first A, B, C, D, E, F. Okay, if you're watching a video, just skip fast forward it, huh? Don't waste your time. This is too bad. Okay, done drawing. Now let me fill in the available partition first. 500, 350, 150, 400, 350, 200. Okay, now worst fit. Process 1, 170. Okay, to do worst fit, you find which one have the highest value, which will cause you the highest fragmentation. 浪费最多的 in Chinese 你浪费最多位置，这个是170嘛，对不对？Best fit 是我们看谁最符合它，跟它最相近的 value， 我们把它放进去的 partition。Worst fit 是我们看谁最大，谁可以给我们最大的差别。OK， 所以500、350、150、400、350、200，肯定是去500，所以 process 1就会 fit into 这个地方。OK。And 你注意看它的 internal fragmentation， 你算500不了，你老师没有睡觉对170OK 170 then you get the internal fragmentation. Let me just press on my calculator 啦500减170 Okay, you see the fragmentation is the highest. Okay, the next one 420 because 420 500 partition you already fit this process 1, right? So your process 2 420, you couldn't find any partition size that able to fulfill this thing. So sadly, process 2 is in waiting Q. This is Q. All right. Now the next one, P1, P2 settle. P3, 280. So same. Among all here, you choose which one will make you having a highest difference between not highest difference between highest fragmentation one. Okay, so 3 definitely is going to be 400. Like you choose for the highest value to make it simple, right? You just choose for the highest value compared to this one. So here you will fit process 2, process 3. Okay, value of 280. So your fragmentation will be 400 minus 280. 所以你会拿到120. Okay, and process 3 is done. The next one, process 4, 90. So 90, you choose which one is the most highest difference between like the largest value compared to 90. So here you got 350. So your process 4 is going to fit here. You put it 90 over here. Fragmentation is 350 minus 90. Okay, so that would be 260. Okay, the next one, P5220. So 220, you compare 150, 350, and 200. the highest difference will be 350. So you put it here, process 5, and then you put 220, and fragmentation 350 minus 220, then you will get 130. All right, the last one, process 6, because only left for 150 and 200 partition, right? So you directly put into F lah. The only one that can fit at 200. So internal fragmentation is 0. So you see, partition 3 you didn't use, so the internal fragmentation not applicable. You put a dash over here. Okay, so with that being said, right, you can say over here, the total internal fragmentation is something. Okay, how do you get this something? You sum here. But you have to make sure you write this lah. The process 2 is in waiting queue. So that's all for first fit, best fit, and worst fit. I think this is among all is the easiest. If you still don't understand about it, right? What you can do is go and do more practice now. Okay, just go and do practice and then compare, look at the answer, or try to understand the theory first. I would say this is important. If you cannot understand what is fixed and dynamic, right? If you don't even understand what is the terms of fragmentation, that's too bad lah. Okay, you should actually pick up from there. All right, so I will stop the video here and I'll proceed the next part in another video, which is page replacement algorithm.